Welcome back. This is example one of 183 for Math 365. We're asked to solve the first order differential equation system. X dot equals 4x minus 3y, y dot equals 6x minus 3y with the initial conditions x was 0 is 2 and y at 0 is equal to negative 1. All right. To solve this, and we're looking for the complementary solution to the system. So let's look at this and place it from a second order back to a first order, or sorry, from a second order system to a second order single differential equation. So note from the top one here, we get uh, x dot equals 4x minus 3y. If I solve that for y, uh, I get 3y is equal to 4x minus x dot. And then that gives us that y itself is equal to 4x over 3 minus 1/3 x dot. Okay, and now if I differentiate everything once with respect to time, get y dot is equal to 4/3 x dot minus 1/3 x double dot. Okay, so that then allows us to take this one instead of equal to the resulting differential equation from the second differential equation. Okay, so let's say star into y dot equals 6x minus 7y. This gives me, let's see, 4/3 x dot minus 1/3 x double dot. Equals 6x minus 7. And now notice y here is the same y as up here. So we're going to have 4x over 3 minus 1/3 x dot there. So the y dot gets replaced here, and the y that's remaining here gets replaced by this y. Okay, so simplifying and solving and writing it in maybe a more standard notation. Okay. This whole thing simplifies to uh, negative x double dot minus 3x dot plus 10x equals 0. Okay, or we can simplify a little bit more. If I'm multiplying through by negative, you get x double dot plus 3x dot minus 10x equals 0. Okay, so this is now the differential equation that we will look to solve. So to solve this differential equation, this is a second order linear differential equation with constant coefficients. So we can just let x equal e to the r t. If we plug in that, we're going to get r squared plus 3r minus 10 equals 0. This factors to, oh, excuse me, something with r in front. And 3 and 2. This is positive, this is negative, which means this has got to be a negative. It's got to be a positive. So r is equal to negative 5 or positive 2. So this together tells me that x of t is equal to c1 e to the minus 5t plus c2 e to the 2t. Okay. Um, then now that we have what x is equal to, we can take x and plug it back into our equation here, into star. So plug x into our equation star, and we did that, then we get y is equal to 4/3 C1 e to the minus 5t plus C2 e to the 2t minus 1/3. And if we take the derivative of this, we get negative 5 C1 e to the negative 5t plus 2 C2 e to 2t. Okay. We can simplify this, and we can use the initial conditions now on x of t and y of t. So this is y of t here. Our initial conditions were x of 0 is equal to 2, and y of 0 is equal to negative 1. Okay, so if we use these initial conditions and plug them in here, we're going to get an equation for C1 and C2. Okay. And if we do that, then solve for C1 and C2. So this will give us an equation here. Okay, so sorry about that. A little cotton fit. So now that we have the initial conditions and our two equations, we can plug in the values for 0 for t, setting equal that this is 2 and this is negative 1. We get an equation for C1 and C2, substitute and solve. We do that in maxima, and what we get out is x of t is going to equal negative e to the negative 5t plus 3e to the 2t, and y of t is going to equal negative 3e to the negative 5t plus 2e to the 2t. Okay. All right, I hope that was helpful, and I'll see you in the next video.